Hello, welcome back. In this video, we're going to go over an exercise where we will find the equation of the tangent line to the function that involves a trigonometric piece in it. In particular, the function is sine x plus 1/2 e to the x. In fact, the function involves both a trig function and an exponential function. And we're looking for the tangent line at the point. So to find that, we're going to use the rules of differentiation, and we're going to in fact differentiate each piece, or take the derivative of each piece separately. And from the rules, we recall that sine has the derivative of cosine, and this is the constant multiple of e to the x. So the derivative of that is the same constant multiple times the derivative of e to the x. So here we go. We got the generic expression of the derivative of f. And we want to evaluate this function at pi to get to the slope of the tangent line at point pi. So f prime of pi is going to be cosine pi plus 1/2 e to the pi. Well, at this moment, you can use the unit circle to simplify this. Cosine of 180 degrees is the x-coordinate of the point on the unit circle, which is -1. So in short, f prime at pi, again, which is the slope of the tangent line, is equal to -1 plus 1/2 e to the pi. Right, we know the slope and we know the point that the line passes through. We can go ahead and write down the slope point form of the line. So tangent line is y minus the y coordinate. So y minus the y coordinate of the point. So 1/2 e to the pi. Okay. Equals the slope. Let me just put that in parentheses because it's a long expression. At this moment, I avoid using a calculator because that's going to come with decimal places. You're going to keep everything exact here. Times x minus the x coordinate of the point, that's exactly equal to pi. We got the tangent line. And let's look at the graphical outlook of the equation sine x plus e to the x over 2, which is the function that corresponds to the blue graph. And the bottom equation here is the equation of the tangent line. And the graphical outlook confirms that the red line is in fact the tangent line to the curve at the given point. All right, thanks for watching. I'll see you in another video. Bye.